Okay, so here's our basic exponential growth example. We have every 30 minutes, a single bacteria cell will split into two separate cells. Suppose we start with 5 cells in a petri dish. Write a function rule and a now next rule showing how the bacteria will grow. Then make a table and a graph showing the growth of the bacteria population. So first, let's just figure out what's the important information. We have every 30 minutes. Right? This is our time period. Right? That could be important. A single bacteria cell will split into two separate cells. Right? We're going to split into two. Right? This is our growth rate. All right. It says to multiply times 2, because every 1 turns into 2. So from 1 to 2, when we're multiplying, we multiply by 2. Suppose we start with 5 cells. All right, 5 cells. That is, as the start word implies, the start value. All right. Write a function rule, a function rule and a now next rule showing how the bacteria will grow. Then make a table and a graph showing the growth of the bacteria population. All right, so we got a bunch of stuff to do. Let's start with the function rule and now next rule. Right, to do this, we first want to just write down what's the important stuff. Right, we have a start value of, let's get a different color, a little green, 5 cells. All right, we also have the growth rate. And again, we'll go to green of times 2. Right, we're multiplying by 2, doubling, split. This says split, but we're not dividing, we are multiplying. All right, and we also have, and important, a time period to think about. All right, and this is 30 minutes. We want to write this down. It may not come up in, the table, the graph, and the now next rule and function rule because we'll just be using counting for that. But if there were questions being asked about it later, like how many bacteria will we have in 2 hours, that's going to be 4 30-minute time periods. So we'll use 4 as the exponent value. So that could come back later if we're answering extra questions about this. All right. So let's get to red here. Let's look at our function rule. All right, the function rule, we already know from the previous video that it's going to look like y equals a times b with an exponent of x. All right, so y is going to stay y because we don't need to change it to anything else at this point. And then a is going to be our start value, which is 5. All right, and then b is our multiplier, which is 2. And then x. Don't need to change x. X is fine just the way it is. So, we have our rule, right? Y equals 5 times 2 to the exponent of x. One's ready, right? And then we have our now next rule. Oops, need a T. Once again, this is going to look like next equals now times b starting at a. Right, so in our case, we're going to have next equals now times 2 starting at 5. Then we're just using the same 2 pieces of information, right? We have our 5 cells as our start value. We have our times 2 as our growth rate. And we have 5 goes in for A. We have the growth rate of times 2 goes in for B. Same thing happens down here. We have 2 as our growth rate, starting at our start value of 5. All right. So this is what our rule and our now next rule looks like, function rule, now next rule. So that answers the first thing that we've asked for, write a function rule and a now next rule showing how the bacteria will grow. Next, we have to make a table and a graph. All right, so let's go to our next page here. I'm going to write down my function rule here because that's going to be the most useful for what we're doing next. Oops. Made a mistake, that's next. All right, y equals 5 times 2 to the x. So let's make a graph. All right. I'm only doing the positive portions of my x and y axes because I can't go backwards in time to a negative time period, and I'm starting with a certain number. I'm not going to have a negative amount of bacteria. It's not going to happen. So let's look at this. We have 1, 2, 3, 4, 5, 7, 8. That's fine. And we're going to make these kind of smaller and closer together because this is going to represent how many bacteria we have, and that's going to increase very fast. All right, so we'll go by ones on the bottom. 6, 7, 8. And let's see, let's go by tens on here. So we'll have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and at the very top there will be 150. All right. So now let's see. Here I'm also going to make my table over here. Our graph is set up. Let us do a table as well. I'll set this up. Actually, kind of doing them side by side might make this a little easier because I need the values from the table. All right, so let's see. We're going to have number of 30-minute time periods on the top here. And we'll have number of bacteria on the bottom here. Start with time of 0, go to 1, 2. Helps if I can write. Let's go back. 2, 3, 4, and 5. Now, obviously, my table only goes to 5. My graph goes to 8. I can continue. I might not even need all 8 of these on here. All right. So now, let's see. I have a start value of 5, and that goes along with the 0 time periods because I have no time passing. We have 5 bacteria. After one 30-minute time period, we have 10. After two 30-minute time periods, we go up to 20. After 3, we're at 40. After 4, we're at 80. After 5, we're at 160. Right? And we can continue this, but this is enough for us to know what is going on. Right? And we can see that as we went from one time period, multiplied by 2 on this bottom row. After the next time period, we still multiplied by 2 to get from 10 to 20. Multiplied by 2 again to get from 20 to 40. Multiplied by 2 again. And times 2. The numbers on top are consistently increasing just by 1. These are not following the pattern that's going on the bottom. All right. So now, let's graph. starting at 5 and at 0, we're going to put a point right on the y-axis, right? Right on the y-axis, and 0 for the time. Oh, wait. Here, this helps if I label. All right, this is number of 30-minute time periods. All right, and this will be my number of bacteria. All right, now this will work out a little better. So we have 5, and then after 1 time period, we have moved up to 10. After 2 time periods, we are at 20. After 3, we go up to 40. All right, after 4, we're up to 80. Let's see how we're starting to increase way faster at 5. We're going to be up here somewhere at 160. All right, and then we can connect these as best as we can. Right, and we can see the graph, and we can see that it starts way down here low, and then it goes and goes, and it's going to start climbing super fast up into, infinity here. All right, so we've got our graph, we've got our table, right? And these two things represent what's going on in my exponential function. We can see the growth. Our numbers are increasing, and they start increasing faster and faster as we move to the right. All right, please check out the next video for an exponential decay example.